So I'm just going through the section. I just pulled out a few problems. I was just looking at my math lab, trying to give you guys a chance to, get in there and knock out some other problems or some new stuff before we go into something new. Because we have two more sections left out of chapter 5, and then we'll be done with it. So before we be done with chapter 5, I want to give you guys a chance to digest it. So just picking out a few problems out of a few sections. This is 1.2. I'll make sure my right screen is being shared. Yeah. All right. Trying to make sure my stuff is straight. Okay. All right. So we want to find the value of each expression. They give us sine of 37 degrees times cosecant of 37 degrees. What we can use is our recognize that cosecant is 1 over sine. If that's the case, sine over sine will cancel and leave us with just 1. All right. Next one, sine squared of power 9 plus cosine squared of power 9. Here we're using our Pythagorean identity. Sine squared plus cosine squared is equal to 1. So that's just equal to 1. All right. So the next one says secant squared of 23 degrees minus tan squared of 23 degrees. Also using another Pythagorean identity. 1 plus tan squared is equal to secant squared. So secant squared is equal to, is equal to 1 plus tan squared. So I will plug in 1 plus tan squared, and it is a 23. All right. And so the tan squareds will cancel. That parentheses is not, I'll just use that as a grouping to show what was substituted in, but it's not stopping the minus sign from being applied. So tan squared minus tan squared cancels, and that leaves us with just 1. All right. So those few were just getting you to emphasize or emphasizing the usage of your identities. All right. So we want to find a co-function that's equal to the functions that they gave us. Sine of 7 degrees, the co-function relationship is cosine 90 degrees minus whatever the angle is that we had initially. So that would be 7. So that co-function would be cosine of 83 degrees. All right, so same things happen for this tangent of pi over 9, so we're going to use cotangent, and we're dealing with radians, so this would be pi over 2 minus pi over 9. Need a common denominator. That'd be 18 for us. Multiply the first one by top and bottom by 9, second one top and bottom by 2. All right, so that's that. All right, so I'm going to find the measure of the designated side. So in other words, this, here we're looking for this side A. Down here we're looking for side B. All right. So we need to use the trig function that incorporates the side that we know and the side that we do not know. So we're leaning on the relationship of SOHCAHTOA. Sine is opposite over hypotenuse. Cosine, is adjacent over hypotenuse. Tangent is opposite over adjacent. So remember, our hypotenuse is opposite the 90-degree angle. So we cannot use sine or cosine because both of those incorporate the hypotenuse. So what we will use here is tangent. And it'll be tangent of 37 degrees. Opposite of 37 degrees is A. So it's opposite, and the adjacent is 250. All right, so to solve, we'll multiply 250 to both sides. Cancel out on the right. A is going to be equal to 250 tan of 37 degrees. And where's my calculator? I'm getting 188.39. All right, so next one. We have our 34 degrees and we have our hypotenuse. So we're looking at what's beside our 34 degrees, the adjacent over hypotenuse. So we're looking at cosine. So multiply both sides by 220. They cancel, leaving us with B equal to 220 cosine of 34 degrees. And that is 182.39. All right, questions on anything so far? I think I put 1, 2 as a section. I meant 5, 2. Let me go back. Yeah, I put 1, 2 and 5, 2. So yeah, cosine theta is -3/5, and also theta is in quadrant 3. So don't forget, all are positive in this the first quadrant. Sine and cosecant are positive in the second quadrant. Tan and cotangent are positive in the third quadrant. And then cosine and secant are positive in the fourth quadrant. Also, we need y. I'll get cosine is x over r, and r is always positive. So from this, we know that x is -3, r is 5, and we need y. I guess I could have kept off the square root, something like that. So r squared equal to x squared plus y squared, because we're going to have to solve for y. So I'll go ahead and put the numbers in. All right. So solving for y, we get plus or minus 4. And so that's why it was important to make sure we're cool with what's going on in our quadrants. You know, here we got plus, x and y positive. Here's negative, then positive. Down here is negative, negative. And then the fourth quadrant is positive, then negative. So because we're in quadrant 3, so we have all 3 pieces now. Y will be negative in quadrant 3, and so will x. All right, so just rewriting. So cosine was given. That was -3/5, but it's x over r. We talked about that. Sine is y over r, so it'd be -4/5. Tangent is y over x. It's not 5. -4 over -3, just 4/3. Secant is r over y, and that's not right. R over x, right? So it's 5 over -3. Cosecant is r over y. And then cotangent is 3/4, which is x over y. Note, r cannot be negative. All right. And that's because, just in case anybody wanted to know, we know x and y can be negative. Those are our coordinates, but the formula is x squared plus y squared. So once we square, x and y, that prevents it from being negative. And of course, we couldn't take the square root of a negative without tapping into imaginary numbers. So yep, r will always be positive. So that's why when we go back here, when it gave us cosine, we knew that that negative was going to be given to the x, because that's x over r. But we knew the negative, that was a -3 over +5, because r will always be positive. See the chat. Still know the fact that imaginary numbers are jerks and not to be spoken of. Too funny, too funny. Let's see. Guess we can do one more like that to make sure we're good. Let's go with tan theta. All right, so we're looking at tan theta of 5/12. Tan theta is equal to 5/12. And cosine theta is less than 0. So don't forget, if tan is less than 0, that means cosine theta is negative. Also, recognize that tan is positive. And there's only two places that tan could be positive. It's either in this quadrant or this quadrant. And since we know cosine is negative, that means we have to be in the fourth quadrant. Also, if cosine is negative, that means in order for tan to be positive, that means sine would have to be negative as well. So just re-emphasizing the fact that we're in this fourth. I said fourth quadrant, I meant third. I was pointing at 3 and I said 4. Sorry about that. So tan theta is y over x. So if that is the case, that means y is equal to -5, x is equal to -12. And we need r. All right, so we have tan, we have x, y, and r. So we can go ahead and write the rest. Sine is y over r, so that'll be -5 over 13. Cosine x over r, -12 over 13. Tan we saw was given already. And that was 5 over 12, right? Yep. Okay, cosecant. R over y. Secant r over x. Then cotangent x over y. Yep. All right. Problems, questions, concerns. All right. Let me see. Do I want to do that? So, did anybody have any questions? Everybody good so far? Straight? See head shaking. Okay, okay. So this is what I want to do. For the most part, and I mentioned the last class, 5, 5, 5, 6 are graphs. So I want you guys to get in there, familiarize yourself with the graphs. They're gonna have graphs up there, and if you have a graphing tool, you can just go on the internet, type in graphing calculator. You should be able to type them in and get the same thing. And they'll ask you to identify which graph goes with which and everything like that. So I will mention amplitude and period. We already talked about period, but just to make sure we're good on that, just on next class before we go into the next section. And then we will go from there. Look to finish out 5-7 and 5-8. And we'll talk about how we're going to do. I'll tell you now. I'm gonna post a test for chapter 5 after we close out 5-8, and so you'll take it. I haven't put a due date out there or anything like that. We'll talk about that as well. But you will take the test. I'll give you 2 chances to get the best grade possible. Whatever your final submission is, make sure you email me your scratch work. And yeah, we'll go from there. It won't be proctored, so you do it on your own time. It will not be timed, so be on you to just get it knocked out as soon as possible, for the due date. All right. So take advantage of this time. Like I said, try not to do anything new today. Trying to give you guys a chance to get into my math lab and knock that stuff out before anything else hits you in the face. I see somebody else shaking their head, yes. So if you have any questions, feel free to stay back. If not, I will see you on next class. And we will go from there. You guys have a great weekend. No problem, no problem. Roughly how many questions on the test? Around 20, maybe less than that. I have to look at the, it depends on the complexity of the problems that I'm choosing. Try not to hit you guys too hard. I don't want to really go over 20. But I don't want to make it like 10 problems, because then if you miss one, that's 10 points off. You miss 2, that's 20 points, So I'm trying to create that balance of not too many problems, but at the same time, giving you a chance to miss one and it not be the end of the world. So I guess around 20, maybe 21, 22 at the most, something like that.
Do you pull them from a bank, or is it like how closely will they resemble the stuff in the homework?
It will be the problems that you see in the homework.
Okay.
I'm gonna create a test review that's not mandatory, that will set you up as far as letting you know what you should be looking at going into the test. So, you'll know what's going to be on the test. I may have maybe I will put like 25 or 30 problems on the test, but on the test review, and then scale it back for the actual test. I may do something like that, but it will be same type of problems. You'll know I can't even get it out. You'll know what's going to be on the test before you go in there. All right. Anything else? Anybody else? All right. So I will see you guys next week. If you have any questions, feel free to bring them up next class or shoot me an email. Outside of that, have a great weekend.
Thank you.
All right. Thank you. All right, take care.